Hi, this is Simon from Precision Piezo. We're just going to talk through how my underbed piezo sensor system works. So what we have essentially are three parts. Two of them are currently joined together and they are here. There is a lower part which has one fixing screw, which is M3, with a recess for the screw head, and then there is this middle part which faces downwards and is actually bonded just with some super glue, or we could use acetone if it's ABS, around the rim. The important thing is that this middle part does not push down particularly hard on the piezo disc, although, you know, a little bit of contact doesn't really matter. And then we've got the upper part. Now this is the part the bed sits on, so I've cut out the shape of my bed out of this upper part, and it has this little plunger on the underneath. Now it's important that the plunger fits tightly into the hole, and that if we look from the side we see that, you know, there is a little bit of a gap there between the upper part and the middle part, which means that the plunger will press the piezo disc when you press down on the bed. Now essentially there's three of these spaced equally around the bed. I've extended the piezo leads here just to some standard DuPont connectors, which are connected to the piezo kit version 1.21 PCB, although any of the Precision Piezo PCBs will do this. If you don't have the kit one, if you have the one for the Piezo 20 module, which only has one piezo connector, then you just connect all three of these leads from the three piezos all together in parallel and connect them to the one piezo input. It's important that the polarity is the same on each of them, so it might be worth just connecting them individually and just have a little press on them. And if I show you the blue LED, you can see that as I press it we get a trigger. Now if I push down and release, we don't get a trigger. So the piezo polarity is correct on this one, and again you can repeat and then repeat here. And what's important is that essentially it triggers when you tap, not when you let go. So they're all connected to the piezo PCB, which you can see if you look at my series on making the Piezo 20 module. How to tune the PCB is exactly the same as in that video, which I think is part 6 in that series, so have a look on my YouTube channel. We then have the bed. So essentially it's only a micro printer, but the bed's just 120mm. It's reasonably snug in these fittings. We push it on here, get it in between the fittings here. Now you could redesign these with some little clamps to sit over the edge of the bed, much like my Cossel XL has here, you know, where the clamp is probably bigger than the bed on the micro printer. But, you know, I mean, in this case the bed's pretty firm. I mean, it doesn't move around. And when we look at the LED, we can see how just minuscule amount of force it takes to actually trigger it. In fact, if I show you the LED now, I'll just blow on it, and we can see that it triggers as we blow on it. Now you may have to turn the sensitivity down. I mean, what I've done once I've connected it all up is to fire the printer up, home the effector there, and just see how much the vibration through the frame actually affects this. If it affects it quite a lot, take a little tiny bit of sensitivity off using the VR2 or left if it's the Piezo 20 PCB adjuster. So you just turn it till the blue light comes on, and then turn it till it goes off, and just a tiny little bit more. Now I've actually got this one set up the other way round. This is set up as normally closed, so on this particular type of PCB, not the Piezo 20, please don't do it with the Piezo 20, but on this PCB you can leave it so that the blue light is just on, and that will give a normally closed signal to the printer controller, and the LED will go off on trigger. I hope this helps.